Bismillahirrahmanirrahim. This video will be discussing practice problem 16.1, and this is about state diagram part of Laplace transform of Mr. Alexander and Sadiku's book of circuit analysis. And this is on the request of a student. So before we begin, two things you have to keep in mind. In an electric circuit, the state variables are the inductor current I and the capacitor voltage V, since they collectively describe the energy state of the system. So you see the capacitor and the inductor, they are the energy storage elements. And so the voltage across capacitor and the current through the inductor, they are called the state variables. We'll be using this term. And two equations basically will be solving. The complete state model is this one, x dot. I hope you recall from your calculus that dx dt can be written as x dot. So this is dx dt. Then ax plus bz. This is the state equation. And this is output equation. Y is for output. Cx plus dz, this is the output equation. And as we go, we'll discuss that. Now, this is the question given. First of all, the advantage of state diagram is that it can solve a circuit having multiple inputs. Like here, you can see two inputs and multiple outputs. So we'll be taking V0 and I0 as output variables. So this voltage here and this current. And the answer is also given because it is a practice problem. So we'll try to match this answer. And I have taken help of this website. So thanks to them. Okay, so a couple of things I have done in this circuit. First of all, mark the output variables V0 and I0. And then I have also marked the two inputs, input I1 and input I2. And this equation that we already discussed, the first or the state equation we'll be using to find V dot, that's when this voltage here, capacitor voltage, dV dt, and I dot, that is the inductor current di dt. The second equation or the output equation we'll be using to find V out or V0 as shown here and I0 in this circuit. Okay, couple of more additions. Since the resistors are not marked, I have marked them as R1 and R2. Also, I have marked the capacitor voltage as V and the inductor current as I. Also, these two nodes, I am calling this whole node as A1, 1, and this is 2. And now we'll take the first node at node 1. We'll write the KCL equation. Current entering, I is the current entering. And then you can see this current leaving, this current leaving, and this current leaving. So instead of writing in terms of I1, I2, I3, everything, let's straight away convert the currents into voltage. So I1 is entering equal to this current is actually this voltage divided by R, because these two are in parallel, therefore it will be voltage divided by R1. So this is the current through the R1 resistor. What about the current through the capacitor? We know the current through the capacitor is given by ICV dt. So I is equal to CV dt. So it is C dV dt you have written. And the third element is the current through the inductor I, so we are calling it I. And from here, I've changed this to the convention that will be following in this chapter. That is dV dt will be called as V dot. And from here, we'll find V dot. We'll just arrange it, divided by C, and moving this to the left and I1 to the right. So we will get this equation. I hope you can easily do this. So we were here. Now keep in mind that we are dealing with this equation, the state equation. Two variables of the state equations are the V and I. So we're trying to find V naught first of all. Now the point to note in this is that X is the state variable. So X should be in terms of V and I. So let's see, the first term is in terms of a B, fine. The second term is in terms of I, that is also fine. The BZ term, Z is the input variable, and our input variables are I1 and I2. Now, in the upper part, you can see only I1 is given, I2 is not given. So to complete the equation, we'll write it 0 multiplied by I2. So this is our complete equation. And this is called the one of the state equations, first one. Then we have found V dot. Now we need to find I dot. I dot means di dt. Here, di dt. We need to use KVL around the loop containing C, L, and R. That means we need to use this loop here, this loop, and you can start from here, minus V in terms of voltage, keep in mind. Then this will be plus VL, which can be written as L di dt, so L di dt or I dot, and then plus 2 into I dot or R2 into I dot. So this is in term for I naught. Here also we'll try to arrange I1, we have got into the left, dividing everything by L, so we get this equation. And same logic will follow. This is not state equation because I0 is not input variable. This is not input variable. So we have to change it to the input variable. And how do we replace I naught? I naught, we have from the node 2, you can see we are here now. From node 2, current entering is current leaving. That means I naught is leaving is equal to I and I2. So from here we can now replace this I, these values. So replacing I for I and I2, we get this equation. And now here also you can see same logic that we had used, that we have the two state variables V and I, but we don't have the two inputs. We only have one input I2. So we got to incorporate I1 by multiplying it with 0. So this part remains same. Here we are just adding a 0, 0 I1 minus. So this is the second state equation. So we have got two state equations for V dot and I dot. And from here now we can write in matrix form. This is the state part and this is the output part. Okay, so the input and then the coefficients, and then we write the V and I2 variables. I hope you know how to write the matrix form. Plus same here, we write the coefficient 1 over c, then 0 and minus R2 over L, and the variables I1, I2. So this is state model uh, for the given circuit. Now we'll find the second part, that is the output part. Same logic. We have to, from the circuit, we can see that V0 is equal to V, because this voltage is same as this voltage. So V0 is V, and the two outputs, if you recall, it was, we have to find V0 and I0. So V0 from here, and here also we'll follow the same logic, because we don't have all the four variables. Like the state variable, we only have V, so we'll put I with 0, so I with 0. Similarly, we don't have anything about the input variable, so we'll put both of them with 0, 0 I1, 0 I2. Then at node 2, current I0 is I into I2. We have already discussed this at node 2. And so from here, we'll calculate I0. Now, this is the state variable I, but we don't have state variable V. So we'll write it with 0, 0 Vi. And similarly, the input variables, we only have I, so we'll put I1, sorry, I2, we'll put I1 with a 0. So this is the second equation. And this, from this, we can also write in terms of a matrix, two outputs V0 and I0, and comparing these two. First of all, this part is 1 and 0, and from here 0 and 1 Vi, and the second part is 0, 0, 0, 1, 0, 0, 0, 1. So these are the two matrix equations that we have found. And now we can try to find the values. So we'll just plug in the value of R1, C, L, and R2, and the answer will be like this. I hope you can solve this, putting in the value of R1 and C here. And so this will be the answer. And this is what is the answer given in the book, this for the first part. And second part, since there was no ABC in here, so it is the same value. So this is the book answer. So this is how you solve. The question has only asked to find the state variables or state diagram. It has not asked us to find the transfer function. But the if you see example 210, I guess, then in that the transfer function was also calculated, which is slightly tedious method. So please let me know through your feedback